An infinite geometric progression has first term as x and sum equal to 5. Then x belongs to. So it says that there is an infinite GP and its first term is x. First term is given as x. The sum is equal to 5. For an infinite GP, let's say for an infinite GP, if my first term is a and the common ratio is r, the sum is given as a upon 1 minus r, and the condition here, the important condition here is that r is between minus 1 and 1. R is between minus 1 and 1. And this is the important mistake, that this is actually the most common mistake that most of us do, because we know that the sum for an infinite geometric progression is a upon 1 minus r, but we most often just forget this condition, that this common ratio r should be between negative 1 to 1. Having said that, now let us substitute the values. So a is my first term, which is given as x. So x upon 1 minus, let the common ratio be r itself, and this value is given equal to 5. Now, how can I find from where to where this x belongs to? So one condition that we just saw is that r is between minus 1 to 1. So if we can somehow rewrite r in terms of x, then instead of r we can substitute that value, and then we can finally proceed and find the range of x. So let's try to do that. So from here, x upon 1 minus r is equal to 5. If I take reciprocal on both the sides, I'll have 1 minus r upon x is equal to 1 upon 5, which gives me 1 minus r is equal to x upon 5, and this means that 1 minus x upon 5 is equal to r. This is the value of r in terms of x. So now in this inequality here, instead of r, I'll substitute this value, 1 minus x upon 5. So this will give me negative 1. Instead of r, I'm substituting 1 minus x upon 5. Now this value should be between minus 1 and 1. Now let's do one thing. Let's try to remove this 1 from here, and I can remove 1 by subtracting 1. So I have to do that throughout. Negative 1 minus 1 greater than negative 1 plus 1 minus x upon 5 greater than 1 minus 1. So I'm subtracting negative 1 from all the three terms present here. So this gives me negative 1 minus 1 is negative 2, greater than this and this cancelled. So I'll have negative x upon 5 greater than 1 minus 1, 0. Now since we have a negative value here, I need to multiply throughout by negative 1, and we know that if we multiply anything with negative, if we multiply a negative sign in the inequality, the sign of inequality reverses. So I'll multiply negative 1 times negative 2. So I'll just reverse this inequality, greater than negative 1 times negative x upon 5 greater than negative 1 times 0, negative 1 times 0. And if you are thinking why the inequality reversed, so let me give you a simple example here. Let's say that if 2 is greater than negative 1, this is a correct statement. Now what will happen if I will multiply negative 1 on both the sides? So this means negative 1 times 2 should be greater than negative 1 times negative 1. I have multiplied negative 1 on both the sides. So this means negative 2 is greater than negative 1 times negative 1 is 1. Now this is an absurd statement. This is never ever true. Negative 2 is not at all greater than 1. So in order to rectify this error, we generally tend to reverse the inequality sign. So the moment I'll reverse this, this will become negative 2 is less than 1, which is absolutely correct. So whenever you are multiplying or dividing with a negative value in an inequality, just make sure you change the inequality sign. So now let's get back to this inequality here. Negative 1 times negative 2 is 2, greater than x upon 5 greater than 0. Negative 1 times 0 is 0. Now this is x upon 5, so I need only the value of x. So let me multiply with 5 throughout. 5 multiplied by 2, 5 multiplied by x upon 5, and 0 multiplied by 5. So this gave me 5 times 2 is 10, greater than this, and this will be equal to 1. This will become just x, greater than 0. So x is between 0 and 10. So let us see which option satisfies this. X is between 0 and 10. Again, option C is the correct option here.